Hey Math 20-2, welcome to 8.5 similar objects. So this one actually isn't going to be too different than the other ones. We're just going to try a bunch of examples here. So it says a toy tractor has the shown dimensions. The scale ratio, the box says 1 to 16. Determine the size of the actual tractor. So for this one, all we have to do is use our ratio for each one of these numbers. So if we did that, so we have our formula, K, or scale factor or scale ratio, is equal to model over actual. So if we actually just fill in what we know here, we can say, okay, I know what the scale ratio is. I know what K is. I'm just going to write 1 over 16 there, right? 1 over 16, 1 dot dot 16, same thing, is equal to, well, and the model says that this number that I'm looking for is 12.7. So I'm just going to write in 12.7 over, and now I don't know x. I don't know what the actual is. That I'm looking for this height on the actual one, right? So then we just need to solve for x there. So x, if we rearrange this, so if I'm going to have to get x out of the denominator, so I'm going to bring x up to this side, or multiply both sides by x, however you want to think about it. So we'll go x over 16 is equal to 12.7. I'm going to multiply both sides of the equation by 16. So times, or dot 16. So x is just 12.7 times 16. That's going to give me my height of my tractor. So if you do that, you get 203.2 centimeters. Okay, how many meters do you think that would be? Well, there's 100 centimeters in a meter, so I just really have to move my decimal place to the left twice or divide by 100. So this would also be equal to 2.03 meters. So the height of my tractor is really pretty much 2 meters, I could say. Okay, and then you just need to go ahead and do the other two. So go ahead and do the same for the width and the length of the tractor. So that's going to give you that one and that one. The processes are exactly the same, so I'll let you guys go ahead and do that. Okay, so for this one, we're going to do the same thing. I just wrote the formula down again. So it's the diameter of the rear tires of the real size tractor is 1.2 meters. How big will the rear tires be on the toy? So we just got to fill in what we know again. We know from up in the question that the scale factor is 1 to 16. So just fill in K with 1. Oh, pen's not working. 1 minute. Okay, I got my pen back working. Okay, so 1 over 16 instead of a K is equal to, now this time we don't know what the model is. That's what we're looking for. So now that's going to be x over, and we do know the actual size of the tire is 1.2 meters. Okay, so if you solve for x there, you could just go and cross multiply if you want to do it that way. 1.2 times 1 divided by 16 gives you x. So x is equal to 0.075 meters. And make sure that you got your units correct. We were dealing with meters there, so our answer is going to be in meters. And that's not a very handy way to think about it, so I'm going to rewrite this, but instead of meters, I'm going to write this as centimeters. So this would be, you move the decimal place 2 times over to go from meters to centimeters, because there's 100 centimeters in 1 meter. Or you can multiply by 100, that's another way of thinking about it. So that would be 7.5 centimeters. All right, moving on. Okay, now this question is actually really similar to the first question with the tractor. The only difference here, what makes it a little bit tougher, is that we're dealing with imperial system. We're dealing with inches instead of good decimals, right? Fractions are kind of annoying if you don't have to use them. But we can deal with it. So it says Tammy has found plans for a bookend in a woodworking magazine. The plans include a scale diagram with a scale ratio of 1 to 5. Determine the dimensions, so just like the last question, of the actual bookcase. Okay, so we're going to call this the length. Let's get this all straight first. We'll call that the length. Okay, so yeah, that'll be the length. The width would be that one. The height would be the up and down. And then base thickness, that's going to be this, right? I'll call that BT. All right. So really, we just got to find all those again. So we're going to start off by looking for the, it's not a very good L. It's an uppercase L. Okay, so length, if we want to find that. It's going to be the same thing. So we're just going to go 1.5 this time instead of K is equal to, and it's going to be the model over the actual. So the model is what we have here. It's 1.5, but 1.5 is really annoying to use. So what I'm going to do, instead of calling it 1.5, I'm going to call it 1.5. That's going to be a lot better to deal with than using fractions in their numbers. So 1.5. That's going to be really the only difference between what we're doing here. So if we do that, we go 1.5 x, and then we solve for x. You get x is equal to 1.5 times 5. So x is equal to 7.5 inches. So if you didn't know that, those two dashes mean inches, right? So 7.5 inches, but that's not usually the way we talk about inches, as being like 0.5, 7.5. That's how we can talk about centimeters being that way. But inches with the imperial system, we want to have that written like x is equal to 7.5 inches. That's the way you'd read it on your measuring tape, and that's typically the way we deal with imperial measurements. Okay, so that's the length. The rest of them are really similar. These two should be really straightforward because there's no fractions in them. I want you to go ahead and see if you can do the base thickness one too, though, because now we're dealing with a quarter. And it's going to be the similar process to what I did for length. So I'm going to let you guys go ahead and do that. All right, so this one says Sandy is a chef. In her restaurant, she uses plates of various sizes and shapes. Are her plates similar? So you're going to ask yourself, what does it mean by similar? Similar just means that all the dimensions you can multiply by the same scale factor, and it'll all be the same. So it doesn't matter, like if we look at these ones down here. So if this is length and this is width, length and width. If the scale factor of changing one to the other was, let's say, 2, that means I can multiply the length by 2 and get that one, and I can multiply the width by 2 and get that one. So they have the same scale factors. So all we have to do for that, to make sure that they're the same, is if we go this number divided by this number, it should be the same as this one divided by this one. And D stands for diameter and C stands for circumference in the case of this circle. Because they should have the same scale factors. So let's try that. So if we went 30, so that one there, divided by 6 of this one, well, that's equal to 5. If we go the circumference of that one, 94, divided by 18.8, that's also equal to 5. So it is similar. And you might ask yourself, but what if I got that backwards? What if I went 6 divided by 30 and 18 divided by 94? Well, that wouldn't matter. You could do that just as well too. The real thing here is whether these two numbers are the same. So they would be different numbers, but they would be the same number, right? It would be a decimal in that case if you went the other way. Yeah, so those are similar triangles. So I'm going to let you guys go ahead and tell me, do you think that these ones are similar triangles, or similar rectangles, I guess, in this case? All right, so I'm just going to get you guys off in the right direction for this one, too. I'm going to let you guys go ahead and do the last one. So it says a city engineer, or sorry, Cindy is an engineer. She's working on a city project replacing old storm sewer pipes with new concrete pipes. Each pipe has an inner diameter of 1.5 meters, a wall thickness of 18 meters, and a length of 2.5 meters. Draw a scale drawing of the pipe using a scale factor of 1/20. Okay, so all you really need to do here is pretty much everything we've done so far. So it says it has an inner diameter of 1.5 meters, thickness of 0.18, so that'd be that one, right? That's the thickness. I'll put like a T there, and a length of 2.5 meters, so that's up here. and draw a scale diagram. So you're going to draw something like what I've drawn down here, this green tube. But your numbers are going to be different than these numbers now. They're going to be the ones that have a scale factor of 1 to 20. So just do what we've done before. Sketch out a diagram like this and label it with the new numbers, and you're done. So I'm going to end that video there. The questions I'd like you guys to do are right here. They're also on my website. So when you're done that, go ahead and finish those questions for me. And I'll see you guys in class.